Welcome. Today we're going to be working on vertical and horizontal lines. So our content objective is students will be able to create a line with a slope of 0 and undefined. Our language objective is students will be able to state verbally the difference between the slope of 0 and undefined. And why am I learning this? Well, it's important for solving real-world problems like finding out how quickly the amount of water in a reservoir is changing. So first, I want to go over some background knowledge. How did we find the slope off of two given ordered points? So what we would do is first plug it into our formula. We always take second minus first and we do vertical change over horizontal change. So in this case, we would get 0 over 3. Now here, whenever there's zeros involved in a fraction, you need to be careful, okay? One thing you need to remember is that you cannot divide by 0. You cannot. Can you have 0 as a numerator though? Yes, absolutely. Here, the slope would be 0. But now take a look at this one. Here, if we were to find the slope, we would end up with negative 3 over 0. Here, we're actually dividing by 0, which is big no-no. This does not work. You cannot divide by nothing. So here, your slope is undefined. So remember, there's a difference between the two. Here, 0 is in your numerator and it's being divided, which can happen. You can take 0 and divide it by something, but you cannot divide by 0. So here, it would be undefined. So you want to make sure you know the difference between those two. So in this case, if I were to graph this line, it would be a horizontal line. And the reason why I want to talk about this is, what is the slope? The slope would be 0. So in this case, there are two ways you can read this. First of all, you can say, if you read it from left to right, notice nothing is happening. It's going in the same direction. It's not going up and it's not going down. Therefore, you can say the rate of change is 0. Nothing's happening. Or you can think of it in terms of rise over run. Notice there is no rise. No matter how far we run, there is no rise. So we can say the rise is 0. The run can be any number you want. Here you can say it ran 1, 2, 3. Okay, it would be 0. So notice again, you can have nothing and divide it however many times you want, still be 0. So here it's possible. But now let's take a look at our vertical line. If we graph these 2 points, you'll end up with a vertical line. Notice, in this case, our slope is undefined. So why is this? Well, like I said, before we would normally read graphs from left to right. Notice I can't really read this graph from left to right, okay? If I were to scan over from left to right, it would only touch at one point here. So here, there is no rate of change. It is undefined. Now, another way you can think of it is this. Well, what's my rise? From here to here, it's rising 1, 2, 3. So my rise is 3. Well, what's the run? It doesn't run at all. So it'd be 0. So here, notice you can't divide by nothing. Okay? It's impossible. So here, remember the rule, you can't divide by 0. So this one would be undefined. So again, note the difference between the two. Okay, so just a friendly reminder, we do read graphs from left to right. So in this case, it's going upwards. So we're going to refer to this as uphill. Okay, and this one's going downwards from left to right. So we're going to refer to this as downhill. Here, from reading it from left to right, okay, this one, of course, is called a horizontal line. The slope is 0. Why? Because it doesn't go up, nor does it go down. Nothing's happening, so it's slope of 0. Here, reading it from left to right, notice there's nothing happening except at one point. So in this case, it is undefined. Okay, again, you can think of this as, hey, the rise could be whatever number you want, but it never runs. So your denominator would always be 0 in this case, which would cause it to be undefined. Okay, just a friendly reminder, this is going to have a positive slope, forgot to mention that, and this would have a negative slope. Okay. Okay, so we're going to go ahead and review how to graph and find the slope of a line that looks like these types of equations. Y equals a number or x equals a number. So hopefully you recall how to graph these types of problems. So first of all, since it says y equals 3, I'm going to go ahead and start with the table. Okay, since it does say y equals 3, what do you think y is going to equal? If you guess 3, you're correct. So I'm going to go ahead and put in 3. Maybe about 7 times. Is that more than necessary? Absolutely. But just for good practice, I want to prove a point here. Here, no matter what, I'm going to go ahead and put any value I want for x, because it could be. So I'm going to go out from -3 all the way to +3. So now I'm going to go ahead and plot these points onto my graph. And notice here, I end up with a horizontal line. And just a friendly reminder, another way of reading this is it's going through the y-axis at 3. So notice it is cutting through the y-axis where? At 3. But the main thing that we want to talk about right now is the slope. What is the slope? So notice I'm going to read my graph from left to right. Notice, reading it from left to right, nothing happens. There's no rise, right? So here I'm going to say that the slope is 0. Now looking at this example here, I'm going to go ahead again, create a table where all the x's are -2 since that's what it says. So all the x's are going to be -2. So I'm going to go ahead and put that 7 times. What am I going to put for y? Well, I'm going to go ahead and put any values I want. In this case, I'm just going to go from -3 to +3. I'm going to plot my points and notice I end up with a vertical line. So here, again, another way you can read this is it's cutting through the y-axis. So notice this line does indeed cut through the y-axis, which can be found here. Where does it cut through? It cuts at -2. So here, I would say the slope is what? Well, I'm going to go ahead and scan over and read it from left to right. Notice it only touches the line graph once, and then it stops. So here, it would be undefined. Nothing's happening, okay? But I'm going to go over one more thing before I move on to the next slide. So the other way you could have done this is say, hey, notice, what is my rise? It doesn't rise at all, so my rise is 0. What's my run? I'm just going to go ahead and say from here to here, it went 1. So I can say this is indeed 0. I can have 0 as my numerator, okay? Now in this case, what's my rise? I'm going to say my rise is 1, okay? What's my run though? It doesn't run at all, so I would say the answer is 0. So notice here, since I can't divide by 0, this one would have to be undefined, okay? For me, it's a lot easier to just simply read the graphs. Notice I can read this one from left to right. Nothing's happening, and that's why my slope is 0. But notice this one, when reading it from left to right, you really can't. So that's why this one's undefined. So you choose whatever method works best for you, and then go with it, okay? So here, we're going to do the same thing for number 3. We're going to go ahead and create a table. In this case, since x equals 3, I'm going to make all the x values 3. And what am I going to put for y? Well, y could be any number you want. In this case, I'm going to go ahead and choose -3 all the way to +3. If I were to graph this, this is what I would get. Notice, again, it says that it's going to cut through the x-axis. So I'm just going to highlight it real quick. Here's my x-axis. Notice this blue line does indeed cut through the x-axis, but where? At 3. Is that true? Yes, there's 3, okay? So let's do a quick scan of what the slope is. I'm going to go from left to right. Notice, it touches about once. It only scans through once. So here I would say my slope is undefined. But again, you can go back to, hey, what's my rise? Just picking 2 random points, I can say, oh, look, the rise is 1, 2, 3. But what's the run? It doesn't run at all. But notice here, again, you can't divide by 0, so it leads to an undefined slope. Now, what about this one? Ooh, y equals 2x. In this case, we are going to start with the table. Notice here in this one, in comparison to the previous one, it says y equals 2x, not y equals 2.
So we don't know what the values of y are right now. So we're going to go ahead and plug in some values for x. Once we plug in our values for x, we can get an input of y. So in this case, if you plug in 0 for x, y would be 0. If you plug in 1 for x, you get y equals 2. If you plug in 2 for x, you get y equals 4. So I'm going to go ahead and plot these points. So that's my line. Now the next question was find the slope. So here I'm going to say the slope was up 2 over 1. So that's going to be a slope of 2. Now, before we move on, I do want to talk about another way you could have graphed this. If you wanted to, you can think of this in terms of slope-intercept form. You can say, okay, well, it's going to hit the origin. The slope is 2, so it's going to go up 2 over 1, up 2 over 1. Let's even go backwards so we can see the rest of the line. You'll notice it's going to create the same exact line as this one. So whatever method you do, it's going to work. However, this one is a lot quicker than this method here. Is it wrong to create a table? Absolutely not. But I want it to be your last resort. If you know slope-intercept form, definitely use that first, because again, it's going to save you some time. If you forget, that's when you want to revert back to using a table. That's going to be your last resort. Okay, what about number 5? Again, I'm going to create a table. Here I know that the y equals -2, so I'm going to go ahead and put -2 for y since I know the actual value of it. I'm going to go ahead and pick whatever values I want for x. In this case, I like to use -3 to 3. Could you use some other numbers? Absolutely, but remember, you always want to keep the numbers small enough so that they can fit on your graph. Now that I have some ordered pairs, you're going to notice you have a horizontal line. So here, we have to figure out the slope. Well, reading it from left to right, I'm noticing it's not going up, it's not going down, so I'm going to say the slope is 0. But another method you could have done is choose 2 points. You can say the vertical change is 0. The horizontal change is 1. So here the slope is 0. So again, there's 2 ways of doing it. You can definitely pick 2 points and find vertical change over horizontal change, or you can read a graph. So in this case, you could actually read this from left to right. It actually works. So since it didn't go up, it didn't go down, the slope was 0. Okay, so now what we're going to do is talk about the line of a graph. What should it look like just by simply looking at an equation? So for number 6, it says y equals 6. Well, first of all, it's going to cut through the y-axis, and the way to cut through that is by using a horizontal line. So I'm going to say it's going to be a horizontal line. How do I know? Because it's cutting through the y-axis at 6. What about number 7? Number 7 says it's going to cut through the x-axis. The way to cut through the x-axis is by drawing a vertical line. So I'm going to say it's going to be a vertical line. How do I know? It's cutting through the x-axis at -4. And for number 8, so notice number 8 is unlike the last 2 problems. This is actually in slope-intercept form. So I'm going to say the slope is a +4. So because of that reason, it's going to be an uphill. Okay. Number 9, notice 3 is also a slope. Since it's at a positive number, it's also going to go uphill. Why? Because the slope is a positive number. So at this point, I'm going to go ahead and have you pause the video and try numbers 10 through 13 on your own. Okay, so let's go over some of the answers. For number 10, it's going to be a vertical line. How do you know? It goes through the x-axis at 3. Number 11, here, since the slope is a -2, it's going to go downhill. Why? Because the slope is a -2. Number 12 is going to be a horizontal line. Why? Because it goes through the y-axis at -5. And last but not least, number 13 is going to be downhill. Why? Because my slope is a negative number, -1/3 to be precise. So now that we've taken a look at the equation to see the general shape of the graph, let's go ahead and take a look at the equation to determine what the slope is going to be. So for number 14, since it's y equals 6, it's going to cut through the y-axis, meaning it's going to be a horizontal line. Notice a horizontal line doesn't have a rise, doesn't go up nor down from left to right, so we're going to say the slope is 0. For number 15, it's going to cut through the x-axis. So you're going to cut it using a vertical line. Notice a vertical line cannot be read from left to right. So you're going to say the slope is undefined. But another method is you could have picked 2 points and said, okay, so there's a rise. You can say whatever number it is, so maybe a rise of 2. But the run, there isn't a run, so it would be 0. And you can't divide by 0, so that's why it even confirms that it's going to be undefined. So whatever method you want to use. Number 16, what's the slope? Well, this is already in slope-intercept form, so I can see that slope is 3. For number 17, also here, it's in slope-intercept form, so I can see the slope is 1/2. So now I'm going to go ahead and have you pause the video and try numbers 18 through 20 on your own. Okay, so let's go over the answers for number 18. The slope is undefined. Number 19 is very tricky. This is in slope-intercept form. It's technically y equals 1x plus 0. So I can say that the slope is 1. So I'm going to say m equals 1. Last but not least, number 20, I'm going to say the slope is 0. So hopefully you got those right. If not, rewind the video just a little bit so that you can see how I did numbers 14 through 17 to help you out to figure them on your own. Okay, so now I want you to quickly go ahead and give me an example of a positive slope. So there's going to be different answers that you could have possibly put on this graph. Just please make sure that your line goes up from left to right, and that would be good enough for me. What about a negative slope? All you're going to have to do is make sure if you read your graph from left to right, it is going downhill. Okay, so are there other options? Absolutely. Okay, so now we're going to go ahead and practice graphing a slope of 0. So what's that going to look like? Well, if it's a slope of 0, I'm going to make sure that I can read it from left to right. It's not going to go up, nor is it going to go down. So all I need really is a horizontal line. So that's going to be sufficient for a slope of 0. What about an undefined slope? So for an undefined slope, you can't really read it from left to right. So I would draw a vertical line. Okay, so let's go back to also thinking about it in terms of vertical change over horizontal change. You could think of it as this. If you pick 2 points, my vertical change is first of all 0. My horizontal change is 2. So 0 divided by 2 is 0. So this clarifies for me that it is 0. But for number 24, again, if I pick 2 points, let's pick these two. What's my vertical change? My vertical change is 1, and my horizontal change is 0. We can't divide by 0, so this will confirm that it's undefined. Now what we're going to do is go ahead and take a look at a table and determine if it's linear or nonlinear. If it's linear, we're going to answer a few questions. We're going to be asked to figure out the slope as well as the equation. So here in a table, we've done this before. All we needed to do was check the ratios to see if there was a constant rate of change. If it is, then there's a slope, and if not, then there is no slope. So here, what's the change in y over change in x? Well, you're going to set up these ratios as -2/1. That's undefined. I'm going to check the next one. Can't divide by 0. Also undefined. So far so good. They're both undefined. 4/0 can't divide by 0, so that's undefined. -7/0, once again, can't divide by 0, so it's undefined. So guess what? Since it's consistent, it's definitely linear, and we can say the slope is undefined because you can't divide by 0. And of course it's linear. But what about the equation? Well, if you take a look, all of the x's were the same exact number. X's were 3's. So my equation would be as simple as stating x equals 3. Okay, now let's try another example. Same thing here. We're going to check our ratios to see if there's a constant rate of change. We check our ratios as y over x. So here we have 0/4. That's basically 0. Then we have 0/-2. This equals 0. So far so good. Next one, 0/-8 is 0. Last but not least, we have 0/14, which also equals 0. So here we can definitely state the slope is 0 since there was a constant rate of change. And definitely it's going to be linear because, again, there was a constant rate of change. And last but not least, what's the equation? Well, I'm noticing a pattern here. All the y's were -4, so I can state that y equals -4. So now what I'm going to do is have you pause the video and try numbers 25 and 26 on your own. Okay, so we're back, so let's go ahead and check to see how well you did. For number 25, the answer is, first, it is linear. The slope is undefined. And the equation is x equals -1. For number 26, it is also linear. This one, the slope is 0, and the equation is y equals 6. So, hopefully you got those answers right. If not, feel free to go ahead and rewind the video and try the last two examples that I did to see if that can help you solve number 25 and 26. That is going to conclude our lesson for today. Thank you so much for tuning in, and like always, until next time, bye!